Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, welcome to my YouTube channel Learn with Adam. Today we will start new syllabus KPK Book Foundation Physics SSC2 Unit number 13 Electrostatic. Now, today we will solve SLO base according to FBISC requirement numerical problem question number 4 to 6 in part 2. So, let's start the video numerical problem question number 4. In question number 4, the given statement, the potential difference across the plates of capacitor is 500 volt and the charge on each plate is 0.02 coulomb. What is the capacitance of the capacitor? So, according to given statement, first of all, we write the given data. In given data, potential difference V is equal to 500 volt and charge on each capacitor Q is equal to 0.02 coulomb. Now we have required that capacitance on a capacitor that is denoted by C. So we use the formula C is equal to Q upon V because we know that charge is equal to capacitance multiplied by voltage V. So from this formula we can write that C is equal to Q upon V. For solution, we know that C is equal to Q upon V. Then putting the values, C is equal to 0.02 upon 500. So calculate the answer divided by 0.02 divided by 500, that is equal to 40 multiplied by 10 raised to power minus 6 farad. Now the capacitance is equal to C and C is equal to 40 multiplied by 10 raised to power minus 6 farad. Now let's start the numerical problem question number 5. In question number 5, given statement, two capacitors of capacitance is 3 microfarad and 6 microfarad are connecting in the series to a 100-volt battery. Calculate the equivalent capacitance and the voltage across each capacitor. First of all, write the given data. The given data of unit question number 5, capacitance of each capacitor. So, capacitance of capacitor C1 is equal to 3 microfarad. That is equal to 3 multiplied by 10 raised to power minus 6 F, because micro is equal to 10 raised to power minus 6. Similarly, capacitance of other capacitor C2 is equal to 6 micro F, that is equal to 6 multiplied by 10 raised to power minus 6 F. Voltage V is equal to 100 volt. Now we can require that equivalent capacitance S equivalent or CS is the capacitance of equivalent, voltage V across V1 and voltage across C2 is equal to V2. Now we using the formula, then equivalent capacitance 1 in a capacitance of voltage, that is 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2, or Q is equal to C E or CE is stand for equivalent capacitance multiplied by voltage V. Now we can find the solution for a series combination. The equivalent capacitance that is equal to 1 upon CE is equal to 1 upon C1 plus 1 upon C2. Putting the values, then 1 upon equivalent capacitance that is equal to 1 upon 3 plus 1 upon 6. Taking the LCM, so LCM is 6, that is 1 upon C equivalent is equal to 2 plus 1 divided by 6. 2 plus 1 that is equal to 3, so 3 divided by 6 is equal to 1 upon 2. Taking reciprocal on both sides, this implies that C equivalent is equal to 2 micro F. Then we have also calculate the value of Q. For a series combination, the charge on each capacitance is the same. So Q is equal to Q1 is equal to Q2. This implies that Q is equal to C equivalent multiplied by voltage V. That is equal to 2 multiplied by 10 raised to power minus 6 multiplied by voltage value 100. So 2 multiplied by 100 multiplied by 10 raised to power minus 6, that is equal to 2 multiplied by 10 raised to power minus 4 coulomb. Now we can calculate the voltage V1 across C1 and voltage V2 across C2. Now V1 is equal to 2 upon C1, that is equal to 2 multiplied by 10 raised to power minus 4 divided by 3 multiplied by 10 raised to power minus 6. So the voltage V1 is equal to 66.6 volt. Similarly, we can calculate V2 is equal to Q upon C2, that is equal to 2 multiplied by 10 raised to power minus 4 divided by 6 multiplied by 10 raised to power minus 6, that is equal to 33.3 volt. Now we can start the numerical problem. Question number 6. In next question, two capacitors of the capacitance 3 microfarad and 6 micro F are connecting in parallel. First of all, in previous numerical, we can solve in a series combination. Now, here we can given the value is a parallel combination. To an 800 volt battery. Find the equivalent capacitance and each capacitor. So, according to the statement, write the given data. Capacitance of one capacitor C1 is equal to 3 micro F, that is equal to 3 multiplied by 10 raised to power minus 6 F, and capacitance of other capacitor C2 is equal to 6 micro F, that is equal to 6 multiplied by 10 raised to power minus 6 F. Voltage V is equal to 800 volt. Now we can calculate the equivalent capacitance C equivalent and charge of C1, that is equal to Q1, and charge on C2, that is equal to Q2. Now according to the statement, combination is parallel. So, for a parallel combination, equivalent capacitance that is equal to C equivalent is equal to C1 plus C2. That is equal to 3 plus C, 3 plus 6, that is equal to 9 micro F. And similarly, we know that Q1 is equal to C1V, that is equal to 3 multiplied by 10 raised to power minus 6 multiplied by 800, that is equal to 2400 micro F. And similarly, Q2 is equal to C2 multiplied by V, that is equal to 6 multiplied by 10 raised to power minus 6 multiplied by 800. 6 multiplied by 800, that is equal to 4800 micro F. For more values and more videos, subscribe our channel. Best of luck.